do some definitions. Let's go through some definitions. I don't know what just happened. There we go. Now, inverse operations, or the opposite operations, of course, are the following. So the first one we're going to go through is the additive inverse. Okay, so the opposite of addition. So any number, if it is added to its opposite, will equal 0. In other words, if you add a to negative a, my answer is going to be 0. Okay, because what happens with this plus minus in the middle here? What happens with that plus minus? What does it become? A negative. Okay, so it's just going to be a minus a, and they're gone. And then we have an example here, a 4 plus a negative 4. So these are opposites of one another. Will give you minus 4 plus 4, which is 0. So this is what most of us have been solving algebraic equations using. So today is that day to shine. And then, of course, for your multiplicative inverse, says a number multiplied by its reciprocal is equal to 1. Its reciprocal means to the opposite. So if I have 4 over 1, that means I will multiply it by 1 over 4, because these will then cancel out and my answer will be 1. Okay, now let's get going. My first set of equations, I should say solve for x. Now let's get going. Let's look at a, okay? I have a 3 times x minus 6 equals 18. Where do we start with that one? It's all right, LM, welcome. Equals 18. Which one do I get rid of first? I know with BODMAS, we usually go with a certain order. But when you are doing inverses, when we're doing inverses, then we go from the back. So we start with addition and subtraction first, which is exactly what you guys are saying in the chat. So that means I'm going to get rid of the negative 6 first. Now, I know that you guys know it as carrying it over, but the truth is we are adding its inverse. Do you guys agree? So I say 3x minus 6 plus 6 on my left-hand side. But what I do on my left-hand side, excuse me, I have to go do on the right-hand side. So if I'm going to add 6 here, that means I must go to the right hand, add a 6. And then what happens with this plus 6, negative 6 here? What happens with those two? They will cancel out. Okay, so then I will be left with 3x on my left-hand side equals 18 plus 6. And how much is 18 plus 6? 24. Wonderful. We've gotten rid of 1. Now we have to get rid of the 3 that's in front of my x. And once again, if you look at inverses, it says you multiply by the reciprocal. So what is the reciprocal of 3 or 3 over 1? What is the reciprocal of 3 or 3 over 1? Reciprocal means you tip it. You tip them, right? So the reciprocal of 3 over 1 is 1 over 3. Okay. So then you have to multiply this side by 1 over 3. But what you do on the left, you do on the right. That's why you end up multiplying this side by 1 over 3. Do you guys realize that multiplying by a third is the same as dividing by 3? Look at where your 3 is. It is below the line. So this is the same as dividing by 3, which I am sure someone was about to say I need to do, right? So then what is a third times 3? What happens with those 3's? A third times 3. What happens with those 3's? It's like saying 1 over 3 times 3 over 1. They are 1, right? They cancel out. 3 goes into itself once and once. So what is left on my left-hand side? If I have all ones and an x, then I'm left with x. Therefore, x is equal to 24 times a third, or a third of 24. How much is that? Therefore, my x is equal to 8. There we go. Okay. So we're going to be using the rules we've been using the whole time, but this time we know why. We are not just applying them. All right, let's check B. B says 2m plus 9 is equal to 27. Once again, we're starting at the back, so we start with addition and subtraction. So from positive 9, how am I going to get rid of a positive 9? By doing the reciprocal or the inverse. What is the inverse of positive 9? Nice. Seth, minus 9. But what we do on the left, we have to go and do on the right. Tell me again, what happens with this positive 9 minus 9? The positive 9 minus 9, they will cancel out. That's why I'm left with just 2m. Then on my right-hand side, I have 27 minus 9. And what is 27 minus 9? 18. Wonderful. Now, what is the reciprocal of 2? Because now that is what we're getting rid of here. We're now getting rid of the reciprocal of 2. So we need its reciprocal. Nice, guys. It's a half, or 1 over 2. But what I do on the left, I have to go do on the right, times a half. So then a half of 2 is a half of 2 is 1. Okay, so you're just left with 1. And then, so it's just m. Therefore, m is equal to, and what is a half of 18? Or 18 divided by 2, it's the same thing. Therefore, m is equal to 9. Okay, C is a little bit more interesting. So let's take a look. I don't know, it's right, it's there. Okay, C says 4y divided by 3 is equal to 12. Okay, now let's look at this. The reciprocal of 1 over 3 or 4 over 3. You can actually take this whole fraction, guys. Remember, you do reciprocals, right? So what would my reciprocal of 4 over 3 be? Reciprocal of 4 over 3. That will give me, nice, 3 over 4. And why would we do that? Look what happens when you multiply by 3 over 4. So I'm going to say 3 over 4 times 4 over 3. Y is equal to 12, which is over 1 times 3 over 4. I'm going to put whatever I add in color so that we can see what happened there. Let's look here. Okay, we can cross cancel. Can you see that? 3 goes into itself how many times? Once, and 4 goes into itself once and once. So what is left on my left-hand side? What do I have left? Y, just y, equals. Now, let's solve the predicament here on the right-hand side, okay? I can't cross-cancel 1 and 3 because it's not going to change anything. But is there a common factor between 12 and 4 that I can cross-cancel? Between 12 and 4. That is my answer, yes, that's correct. But what is the common factor that I'm canceling out between 12 and 4? The highest common factor. What goes into 12 and into 4? The biggest number that goes into 12 and 4 is what? Is 4. Yes, there we go. So 4, how many times will it go into itself? Once, and into 12, 3 times. So now we're left with 3 times 3 at the top. And what is that? What is 3 times 3 going to give me? 9/1. So then therefore y is just 9. Do you see the reciprocal is a little bit shorter? If you just do the reciprocal, it takes much less time to solve. Let's check with D. X over 2 plus 3 equals 1/2. Okay, we have a 3. Inverse, I need to use the correct terminology. It's an additive inverse. What is the additive inverse for plus 3? My additive inverse for plus 3, that's minus 3 because we're getting rid of it, okay? And whatever I do on the left, I have to go and do on the right. So I'm subtracting 3 from both sides, okay? What are these 3's going to do? I have a positive 3 minus 3 over here. There's 0, so I'm going to be left with x divided by 2 is equal to, what is a half minus 3? A half minus 3. A half minus 3. It's negative 2.5. Do you guys see that? You can convert 3 to an improper fraction. So then you'll be left with a half minus 6/2. And when you're subtracting fractions, you only subtract the numerator. So what is 1 minus 6 at the top? 1 minus 6, negative 5. And this is over. Do we change my denominator when we are adding and subtracting fractions? No, so it's still over 2. Okay, so then x over 2 is equal to negative 5/2, or negative 2.5. All right, now let's do reciprocals here. What am I multiplying by? What is the reciprocal of divided by 2? I said it a bit earlier. Tell me, what am I timesing by on both sides to get rid of this 2 at the bottom? The reciprocal of over 2 is 2/1. Do you see that? This is like saying there's a 1 there. We said if there's nothing there, then there is a 1. So my fraction here is actually 1/2x. So I have to times both sides by 2/1 to get rid of it. Okay, and then what will happen with these 2's on my left-hand side? The 2's on my left-hand side, they will become a 1 because this goes into itself once. So then it's just 1 times x, which means I'm left with x equals. And then if you look on the right, we can also cancel the 2's. 1, 1. Then I'm left with negative 5 times 1. And what's negative 5 times 1? Then x is just negative 5. Okay, I'm going to do the last one. Then I'm going to have a thumbs up, thumbs down. Last one says E. Negative 2n minus 8 is equal to 0. We're starting with subtraction. What is my inverse for subtraction? My inverse for subtraction, minus 8. Nice, it's plus 8. So I'm going to go here and say plus 8. But what we do on the left, we have to go do on the right. Think of this as a scale, right? Imagine you're weighing those old school scales. Okay, now I'm going to embarrass myself by trying to draw. Where there's a package here and a package here, and you're weighing them. If I add 2 blocks here, in order for this to balance, if I add another block there, I must go and add another block there. Okay, that's how an equation works. For it to remain true, whatever changes you make on the left, you have to go make on the right. So that's what we're doing here. And then, of course, my plus 8 minus 8 become a 0. So I'm left with negative 2n over here equals how much? 0 plus 8. So then negative 2n is equal to 8. Wonderful. Okay. And now I have to times by the reciprocal of negative 2n. Negative 2n is technically over 1. That means I'm going to times by 1 over negative 2. Nice, Seth. Okay. As we know, on the left-hand side, these have to cancel out. If they do not cancel out, then you made a mistake. Okay, so therefore, n is going to be left on its own. And let's look here. Let's look here, guys. I have a negative 2 and 8. Firstly, I have a positive and a negative number, so I know my answer is going to be what? I am multiplying a positive and a negative, so I know I'm going to have a negative answer. And then 2 goes into itself once and into 8. How many times? 4 times. So then my final answer is, what is my final answer here? Negative 4. Beautiful. Okay, let's have a thumbs up, thumbs down. Okay, let me zoom out here so you can screenshot properly. And while you're doing that, can I have a thumbs up, thumbs down on using multiplicative reciprocals and additive inverses? Let's hear. Wonderful, wonderful. Okay, there are very few responses. I understand those who just joined, but if you have been here, please do give me feedback. Do we understand? Nice, Yolanda, thank you. I like the funny faces. I enjoy those reactions. Okay. Wonderful. Now let's see. Now that we all understand, we are going to do some more sums. Of course we are, because, you know, yeah, I am mean. So let's see here. A is a little bit easy for me, so I'm going to go ahead and say we must start with B. B says 7B equals 27 minus 5B. What's the problem we have with the sum? I don't know why my B just went haywire. What is the problem we have with the sum? What is the problem we have here, guys? In order to solve the sum, what do we need to do? Look at it. I have 7B is equal to 27 minus 5B. We always want our variables on the same side and our numbers on one side. At this moment, are my variables all on one side? No, so that is my problem. Okay, so let's get moving. So then I want negative 5B to be over on the other side. That means to get rid of it on my right-hand side, what do I have to do? To get rid of it on the right-hand side, what do I have to do? Nice, plus 5B. Nice, Mhlali. That means it is now successfully on the left-hand side, because I'm going to say plus 5B. And then on my right-hand side, it will be negative 5B plus 5B, and they will cancel out and disappear. So then here I have 7B plus 5B. What's 7B plus 5B? 7B plus 5B, 12B is equal to 27. Wonderful. Next problem we have to deal with is this 12 next to my B. And what is my reciprocal for 12? The reciprocal for 12, what am I multiplying by on these two sides to get rid of that 12? Nice, 1 over 12. Okay. Remember, Butlali, if it's just 12, it's already 12 over 1. So reciprocal would mean the opposite of that, which is 1 over 12. These 12s will cancel each other out, and I'll be left with b. So therefore, b is equal to, here we cannot cancel anything. We can actually, I spoke too soon. What goes into 27 and 12? Which number can go into both 27 and 12? 3. And how many times does it go into 12? 4 times, and into 27, 9 times. So then I'm left with, in the numerator, I have a 9 times 1. What is 9 times 1 in my numerator? That is 9 over 1 times 4 in the denominator. 4. Now, I want us to change this to a mixed fraction. Okay. So then again, I say, therefore, b is equal to. Let's change this to a mixed fraction. Firstly, how many times does 4 go into 9? How many holes can I fit into 9? 2. And then what is my remainder? It will be twice, and my remainder will be 1 over 4, which is actually comma 25. Not comma 5, but it's 1 over 4. Because it goes in there twice, which means it will be 8, and we have a 9 here, so 1 is left over. Okay. Let's look at C. This time, my variable is in the denominator, which is a problem for us. Okay. We want our variables to be in the numerator. So how am I going to move that variable to the numerator? We're still doing reciprocals. Does anyone have an idea? I need to times by something on both sides to move that variable to be in the numerator. Okay, Seth says, let's first multiply by negative 1 over negative 2. We can do that. Let's do that first then. So I'm going to say 1 over negative 2 times negative 2 over y is equal to 10, which is over 1, times 1 over negative 2. Okay. Left-hand side, they will cancel out. Okay, once. On my right, I have a positive and a negative. So then I have a negative answer. And how many times is 2 going to 10? Goes into itself once, but into 10, 5 times. Now, we are far from done with the sum. Because is my y on the left-hand side in the denominator or the numerator? Where is the y on my left-hand side? It's in the denominator, so I still have 1 over y, which is not what we're looking for here, is it? So how do I solve that, guys? Anyone have an idea? How do we bring it up? Remember, this is not an exponential equation, so we cannot just move it up and change my exponent. But we can multiply by y over 1. What is that going to do? Let's check. Okay, these y's will cancel out. What is left on my left-hand side? I've canceled everything out. So what is left on the left-hand side? 1. It's not nothing, it's 1. Because it's 1 times 1 over 1 times 1. So we have 1, right? And on my right, I have negative 5 times y. What is negative 5 times y? Negative 5 times y. That's just negative 5y. Nice, guys. Now we have successfully brought it to the numerator. But my problem is this dude over here. So I have one more step to go. And how do I get rid of that negative 5, which is now next to my y? I times by, Remind me what I times by to get rid of a negative 5y. Not divide, I times by. I do divide by negative 5, but I times by 1 over negative 5. Remember the reciprocal, right? Then we can get rid of this negative 5 on my right-hand side, which means y is equal to negative 1 over 5. Okay. Now, I'm not going to write these on both sides like I have been, okay? Now we're just going to do what we've been used to doing. What I mean is, let's look at number D. Or let's look at D rather. Let's look at D. D says 3a plus 3 equals 5a minus 7. All right? We're still using inverses and reciprocals, but we're not going to write both steps because that's how you are used to doing it. What I mean is, I know this 3 will end up on the right-hand side, and what will my sign for this 3 be when it gets to the right-hand side? A negative, that's true. And what about my 5a? My 5a moves to the left-hand side. What will the sign for the 5a be? So it's 3a, and my 5a will end up being a negative 5a equals negative 7 minus 3. Okay. So then what is 3a minus 5a? 3a minus 5a. Negative 2a. Good, guys. Is equal to negative 7 minus 3. Negative 10. Now we're doing the reciprocal. So we divide by what on both sides? Divide by negative 2. Good. Which means on my left-hand side, I'll be left with, therefore, a is equal to, because these two, guys, negative 2 will divide into negative 2 and give you a 1. Now, on my right, a negative and a negative, that means my symbol will be what? If I have two negatives, then my symbol will be positive, and 10 divided by 2 is 5. Okay. Let's move on to E. Negative 9 minus 8x is equal to negative 54. All right, let's get rid of negative 9. When we get rid of negative 9, we know it's going to end up being what's on the right-hand side. The inverse operation of a negative is a positive. So I'm going to have negative 8x is equal to negative 54 plus 9. What's negative 54 plus 9? Negative 54 plus 9. Oh, we have a lot of disagreements there in the chat. It is technically going to get smaller in digit. There we go. So this will give me negative 45. It's okay, Seth. That's why we're doing this, right? So we don't make the mistakes in exams. And then I'm going to divide both sides by negative 8. Okay. These negative 8s will cancel each other and become 1. So therefore, x is equal to, is my answer positive or negative? Positive. And can we simplify 45 divided by 8? Is there any common factor between 45 and 8? No, but we can make it into a mixed fraction. So let's do so, okay? How many times is 8 going to 45? 5 times. And what is my remainder? My remainder is 5/8. Nice, guys. Beautiful. Beautiful, beautiful. Okay, there we go for screenshotters. Can I have a thumbs up, thumbs down on this one? Are we still good when it comes to inverse operations? Wonderful. Okay, I have way more thumbs up and nice smiley faces there, so that's great. Okay, now, of course, we did not do algebraic expressions for nothing, right? We need to use some of our skills there to solve for x. It says solve the equations and check your answer. Remind me again how we check our answer. Does anyone remember how we check the answers? Nice, Seth. You check the answer in your left-hand side against the right-hand side. Beautiful. So after we solve it, we have to substitute it back in onto the left and right-hand side and check if it's correct. So let's look at number 1. Okay, I have a 5 times x minus 1 is equal to 4 times x plus 1. Where do we start over here? Those brackets are a problem. So how am I going to get rid of those brackets? I multiply, or what is my magic word that I'm looking for? Nice, distribute. So I have to take 5 and multiply it by everyone in the bracket, and 4 and multiply it by everyone in the bracket. So 5 times x will give me 5 times x is 5x. And 5 times negative 1, 5 times negative 1. So it's 5x minus 5 equals 4x, and 4 times 1 is plus 4. Now it looks a little bit better and easier to solve, right? So how am I going to solve this guy? What is the problem here? Once again, my numbers and my variables are scattered. They're not on one side. So what will I do with those that are not on the correct side? I'm going to move them over. So negative 5 has to move over, and so does 4x. Now tell me, 4x, what's the sign of 4x on the left-hand side after I move it? So it's 5x minus 4x equals 4. That was already there. And my negative 5, what's my symbol for the negative 5? Becomes plus 5. Beautiful. Okay. So then what's 5x minus 4x? 5x minus 4x. Great. We're already at our last step. Therefore, x is equal to 4 plus 5, which is 9. And we're done. Okay, 2 and 3 are very similar. So I'm going to skip us all the way to 4, which is more interesting. Okay, so this is 3 times m plus 2 minus 3 minus m equals 5. Okay, so we know we're going to distribute here with 3. What is happening with my second term here? What is happening with that term? What will I do with this negative that is outside my bracket? Let's hear. We only change the sign. Nice, Buhlale. Nice. So it's still a distribution, but it's negative 1 because if there's nothing in front of my bracket, there's a 1. So then 3 times m will give me 3m plus, what is 3 times 2? 3m plus 6 And then negative 1 times 3. Negative 3. And negative 1 times negative m. Positive m. Equals 5. Beautiful. Okay, so let's check for like terms on my left-hand side. What are my like terms? Oh, we forgot to check the first one. I just remembered. We'll check just now. Like terms for my left-hand side. I have a 3m and an m, as well as a positive 6 minus 3. So what will 3m plus m give us? It's like saying 3 mangoes plus 1 mango. That is 4m. And then 6 minus 3. That is positive 3 equals 5. Who has to move here in my whole equation? I almost said expression. Which one has to move in my expression? The 3. And if it moves over, which sign will it take? 5 minus 3. So then we have 4m is equal to 2. Wonderful. Let's go on to the last step. What is our last step? I have to get rid of my 4 next to the m. And how will I get rid of it? Divide by 4. Nice. Therefore, m is equal to 2 over 4, which is equal to... No, be careful, it's not 2. But I can simplify it. Which factor can go into 2 and into 4? Nice. It's 1 over 2. Factor, not multiple. Okay, so 2 goes into itself once and into 4 twice. Okay, let's check the first solution, okay? So I'm going to have left-hand side and right-hand side. On my left-hand side, I had a 5 times x minus 1, and here I had a 4 times x plus 1. Now let's substitute the solution we got here, which is 9, into my x. So 5 times 9 minus 1. What is 9 minus 1? 8. 5 times 8. So then my left-hand side is equal to what? 5 times 8, which will give me... Let's hear, guys. 40. Okay. And then on my right-hand side, I have 4 times 9 plus 1. What is 9 plus 1? 10. And what is 4 times 10? 40. Therefore, my left-hand side is equal to the right-hand side, which tells us that our solution is correct. Okay. Let's check the last one. Left-hand side, right-hand side. So my left says 3 times m plus 2 minus 3 minus m. And my right-hand side is just a 5. Okay, let's see. M is a half. So a half plus 2 minus 3 minus a half. Okay, let's get checking. What is a half plus 2? A half plus 2. Let's rather change this 2 to a fraction. How can I change 2 to a fraction over 2? Two wholes means it's going to be... That's correct, Amy, but I want it over 2, not over 1. So that means you have to double that, and therefore 2 wholes is what over 2? 2 wholes is 4 over 2. Okay, minus, Buhlali, that's already the answer. I needed the converted one. What about 3 wholes, guys? 3 wholes will be what over 2? Let's hear. 3 wholes? Oh, we need a crash course of fractions and pictures. Nice, Imi. It's 6 over 2 minus 1 over 2. Okay. So then in my bracket over here, I'm going to be left with, Buhlali already told us, 1 plus 4 at the top, which is 5 over 2, minus, what is 6 over 2 minus 1 over 2? 5 over 2. Okay, now let's do the multiplication here. If I'm multiplying, I just multiply numerator with numerator and denominator with denominator. So then here I'll have 3 times 5 in my numerator, which gives me, this guy keeps moving, 15 over 2 minus 5 over 2. And what's 15 over 2 minus 5 over 2? 15 over 2 minus 5 over 2. Remember, we are minusing the numerators. 15 minus 5. That is 10 over 2, which simplifies to what? Which simplifies to 5. Then we can say, therefore, my left-hand side is equal to my right-hand side. Okay, guys, so this is what they mean when they say check. You go to the original question and you substitute or you plug in the answer that you got. So that means our answer over here is also correct. Because at the end, we ended up with the left-hand side is equal to the right-hand side. Okay. I want to do a few of these before we leave. It's already 1:45. Let's start with number 1. Okay. Number 1 looks a little bit more interesting. X squared minus x times x minus 2 equals 4. I see brackets. What do we do usually? Excuse me, or what are we going to do in this case with those brackets? We don't want those brackets, right? We're going to distribute. That's true. Distribute my x. So then I have x squared minus x times x, which is x times x, which is x squared, and negative x times negative 2 plus 2x. And this is equal to 4. What's going to happen with my x squareds? I have an x squared minus x squared. What is x squared minus x squared? They're gone, right? It's 0. The answer is 0. So then I'm left with just 2x on my left-hand side is equal to 4. Then how do we get rid of this 2x? How are we going to get rid of 2x? Divide by 2. Okay, because these will divide into one another, and therefore my x is equal to what? 2. Nice. Okay. Will they ever give us a variable squared? That is very possible. Very possible. Do you mean the trinomial, Seth? Seth is ahead of the game. I'm not sure if I put the trinomial one over here. No, I haven't. Like before you divide. Okay, I'm not sure what you mean. They can give you a trinomial squared. I've seen that before. That's actually a big possibility, guys. How do we solve a trinomial squared? Let me make up a question here and let's talk about it. If I have x squared, let's say minus 5x plus 6 equals 0. You know this is a trinomial, right? And what do we do when we have a trinomial? Okay, we make the two brackets. Okay, x and x. What is my first symbol according to my trinomial? It's a minus. And does this mean keep or change the next one? Change. So then my second bracket will have a negative. Wonderful. Factors of 6, 1 times 6, 2 times 3. Which ones will give me negative 5 if they're both negative? If they're both negative, which one will give us negative 5? Negative 6 minus 1. Will that give us negative 5? What's negative 6 minus 1? This is negative 7, and that's not what we're looking for. So it is, let's see, negative 2 minus 3. That is indeed negative 5. So negative 2 minus 3. Now, how would we solve this equation, guys? It's actually very interesting. How do we solve this equation? It's here. What does an equation mean, guys? It means the whole bracket, x minus 2, times the whole bracket, x minus 3, is 0. That means one of these brackets has to be 0. Do you guys agree with that part? Beautiful, Botlale. Do you guys agree? If this is true, then one of these brackets has to be 0. Because if this is equal to 0, then I'll have 0 times something, which will give me a 0. Same thing. If this bracket is equal to 0, then I have a 0 times x minus 2, which will give me 0. So where you go from here is to split this question up. So you'll say either x minus 2 equals 0 or x minus 3 equals 0. So one of these brackets has to equal 0 for this to be true. Do you see that, guys? And for x minus 2 to equal 0, that means x has to be what? X has to be what's on my left. Let's first solve this one. X minus 2 equals 0. You take this 2 over, it becomes a plus 2. So it's going to give you 0 plus 2. So either x has to equal 2 or x has to equal 0 plus 3, which will give me 3. There we go. I'm not sure if that was your question, Seth, but that's how you would solve a trinomial. Okay, you're welcome. You are welcome. All right. Let's do 1 or 2 more, and then we can call it a day because it is already 10 to, let's see. Let's do number 5. Looks very interesting. There's a lot going on there. Okay, 8x once again, what is my problem here? What is the problem with this one? We have brackets, right? And how are we going to solve or work through those brackets? By distributing. Okay, so I'm going to times my 8x in and my negative 4x. So let's check. 8x times 2x, what is that going to give us? 8x times 2x. 8x times 2x, 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 8x times 2 Just 16. Remember, there's an x and an x, so this is 16 x squared. Nice. Squared. And then 8x times negative 3. Negative 24x. Moving on to the next bracket, okay? Negative 4x times negative 4x. Times positive, excuse me. Negative 4x times positive 4x. There we go, negative 16x squared. And then negative 4x times negative 1. Negative 4x times negative 1 is positive 4x equals 40. Now what happens with these 16x squareds? I have a 16x squared there minus 16x squared. They're gone. So on my left-hand side, I'm left with negative 24x plus 4x. What's negative 24x plus 4x? Negative 24x plus 4x. Negative 20x. And this is equal to 40. So how do we solve for x here? How do we solve for x? Divide by negative 20 on both sides. Now, if I have a positive and a negative on my right-hand side, that means my answer is going to be negative 40 divided by 20. That is 2. Nice, guys. I'll see you guys on Thursday.